Good morning, everyone, and welcome to our webinar this morning discussing and introducing new features in our recent release, version 17.3. This morning, you're listening to myself, Eric Gant. I am a team member in our technical support group here at Pointwise, and joining me this morning, the director of our applied research group is Nick Wyman. We're going to go through and demo some of the new features that we have in version 17.3 first, and then we're actually going to look at a few slides towards the end of some additional features. And at the end of our webinar, we will allow some time for Nick to handle questions that you may have during the webinar, and of course, those that you may want to ask towards the end of the webinar. So I'm going to switch over here to Pointwise. And what we have is, of course, version 17.3, release 1. And I'm showing a project file here, which is a file that I have imported from a new tutorial that we have created, actually 2 new tutorials for version 17.3. These files and this particular file that I'm looking at, of course, is installed with Pointwise, the new version, so you'll have the tutorials available to you and these files as well. The primary new feature in this release that I want to spend our time on initially is our new Overset capability. And these new Overset capabilities are actually a suite of tools that affect various parts of our interface and our GUI. And so specifically, I want to point out those changes and how you will see them in the code when you start to use it. So first of all, one of the areas is going to be our state icon area in the status bar down at the bottom of the interface. You'll also see some changes in the file menu and the import and export options. Of course, our grid menu is where the primary feature set for the Overset capability is. We have a new panel called Overset that you'll access from that menu. And then finally, in the CAE menu under Set Boundary Conditions, you will also see some additional changes. So what I would like to do is go ahead and first open the CAE Boundary Conditions tab and just look at it briefly so we can see what it looks like prior to setting up for Overset. So of course, as you've seen in previous versions of Pointwise, you have boundary condition number, name, the CAE type for your particular flow solver that you have selected, and also the ID number. So this panel is going to change a little bit when we go into the Overset command and choose an assembler. So I'm going to close out of this. I'm going to go back to the grid menu and choose Overset. And you see that the new Overset panel is actually made up of 3 tabs. The Assemble tab, which is the one that I'm showing currently. This tab has several features available, including a summary table of information for your blocking system and some tools for running the assembler outside of Pointwise. The Attributes tab is where you're going to spend most of your time in terms of setting up Pointwise so that it can export the data necessary for your chosen assembler to run properly. And then there's also an Adapt tab, which I'll talk about briefly in a few minutes. The first thing I'd like to do is go ahead and look at this assembler setting. It defaults to none, which basically means I haven't chosen an assembler to use outside of Pointwise. And that also means that basically all of the Overset tools that affect the GUI are currently disabled. I'm going to go ahead and pull down this menu and choose Pegasus 5. I do get a dialog that pops up anytime you change the assembler setting. It'll pop this up just to indicate that if you've set assembler boundary conditions, that those will be cleared when you change this setting. So now this panel is activated and I can go ahead and begin making changes here. I can set up a name for my project, my assembler project. That name is actually the one that's used for the naming of a directory for temporary files to be written to and other uses. Below that, I have a field here where a node tree shows up, and this is where you actually create nodes and settings for your assembler that determines how your blocks are going to be assembled in your chosen assembler software and what it needs to do for hole cutting and other options. So now that we've set this up, I'm actually going to go ahead and click on OK to exit back out of this panel so that we can just briefly look at the changes that I've referred to in the interface. So first of all, down here at the very bottom in the status bar, as I mentioned, we now have another indicator which shows that we've chosen Pegasus as our overset assembler in the Overset panel. Additionally, if I go up to the File menu and pull down to Import and Export, you can see now that this Overset option for both of those is available. And then finally, I want to switch over here to set boundary conditions again. And now, when I open this panel, I have an additional new column that shows up, which is called Overset Type. Just like for CAE type, if I double click on one of these fields for the Overset type, I get a pull down list which shows me all of the Overset types for Pegasus 5 that I can choose for my boundaries. So just like before, I can just simply click on one of these to select it and use that particular type for the Overset assembler. This is a really nice handy setup or feature for the new Overset tools, because in one place for a given boundary or domain in your grid system, you can go ahead and set up a boundary condition, your CAE type, and your Overset type for your assembler all in one place. So now that we've looked at some of these items that are updated, I actually want to go ahead and reload this file, which has the Overset assembler already set up for us. So I've quickly reloaded the file. It's essentially the same project. But now when we go back to the Overset panel, it's going to look a little bit different because, as in the tutorial, which you can work yourself, it already has my node tree set up for Pegasus to tell Pegasus how to assemble this grid when we run the assembler. Additionally, if I go back to the Assemble tab, the main tab for this particular panel, I can see that the table is filled out with information from the assembler Pegasus, because this grid has already been run through the assembler and returned to Pointwise. So in the table, I have a list of all the blocks that I have in the system, and for each block I have assembler data that's been returned to Pointwise, including fringe, hole, and orphan point information, so that I know all the statistics from the assembler and how the grid has been put together. Finally, the last column here where it says up to date just indicates that these blocks have not been changed since they were run through the assembler, and I know that they're currently up to date with valid assembler information. If I look down towards the bottom of this panel, I have a Run button down here at the bottom, and that's the button that actually tells Pointwise to execute your chosen assembler. So what happens in the background is basically Pointwise will write out some temporary files. Those files are transferred to the assembler. The assembler runs separately from Pointwise, and then the assembler returns new files to Pointwise with the assembled data in it for Pointwise to use. And that's what we have here in this example. This is a good time for me to actually point out a source of information for you. If you go to the Help, just as you always can, and pull up your user manual, the user manual has been updated for you with a new appendix. And if we look at this appendix, it talks about all the things that you need to know in terms of setting up your system so that you can use your chosen assembler, Pegasus 5 or Sugar++. This is also a good time for me to point out that we do not actually provide or ship the assembler software packages with Pointwise. It is up to you to acquire that software separately from Pointwise and install it yourself. But once you do have your assembler in place and installed, the appendix here gives you all the information that you need to be able to set up your system and have Pointwise communicate and work with your chosen assembler. So there are some environment variables that you'll need to set up for each of these assembler packages, and they're all documented with examples here in the user manual. Okay, so that's enough for the user manual. So just getting back to the Overset command panel, a couple of more things to talk about briefly before we move on to looking at some changes in the examine command. I just would like to point out that we do have the capability to run your chosen assembler in a remote fashion on a remote system. That is also documented in the appendix in terms of how you need to go about setting that up. And of course, the commands for this particular panel are also documented in the grid section or chapter of the user manual as well, if you need to do that. So one last thing in this panel before we move on to examine is the Adapt tab. I mentioned it just a few minutes ago. If we switch over to the Adapt tab, it actually gives us a list again of all the blocks. And what you can do is pick a block or blocks in your system, and you can instruct Pointwise to adapt the points or cells in that block using the solver based on your chosen target point types. So let's say, for instance, for these blocks we would like to adapt the grid locally according to donor candidates. We just check that box with the block selected, type in a number of iterations in the iterations field, and then simply click on the Adapt button. This instructs Pointwise to run the solver on those blocks, runs the local adaptation, and returns the blocks to you. And of course you can examine them after you've done the adaptation. So this is a really powerful new capability that's been introduced along with our new suite of Overset tools. Okay, now that we have kind of covered and introduced most of the features of this panel, let's go ahead and click OK to leave. And I want to show just a few of the new capabilities that we have in our examine command related specifically to overset meshing. So I'm going to select first this background block in the display window and go to examine. And for function and examine, I'm going to just choose none because I want to specifically look at only the grid without a diagnostic calculated. This opens up our examine command, which should look very familiar to you with the exception of a new frame here in the middle of this panel, which is labeled Overset Options. This is a whole new set of features related to overset data that have been added to the examine command, which give you a lot of control over how this data is displayed and whether or not certain types of data are displayed. So for instance, right now you can immediately see a bunch of yellow points are being displayed over here in the display window. And let me go ahead and actually turn off the display of my domains so we can see it a little more clearly. These yellow points are the fringe points for the block that I have in examine. So if we don't want to see those right now, we can just simply turn off the display of fringe or donor points here in the middle of this frame. Down at the bottom, there's some other show options for how holes are rendered or not rendered. Right now they're currently turned off. They can be shown as grid or symbols. And then there's also some options for orphan display and orphan donor candidates. Let's go ahead and go over to the Cuts tab. And what I want to do is look at a cut through this block that we have selected. So I'm going to enable cutting. It's popped up a Cartesian plane. Let's go ahead and look at a Y cut instead. And I'm going to select the edge of this cut plane and move it over closer to the symmetry plane. And what we see here is that the cut plane actually has the holes, or the cells that have been removed according to the assembler, Pegasus, cut out of the display or the cut. So this gives you a really powerful visual feedback of the results from the assembler, so that you can see exactly what it has done with the blocks, where it has performed hole cutting, and also, of course, if we wanted to, the fringe points displayed as well along with the cuts. So this is a really nice visualization tool for those of you using these overset features. The next thing that I would like to do is go back over here to the main examine tab, which I was already on, sorry. And what we're going to do is go down to the selection frame, and I'm going to change blocks real quick. And I'm going to pick this wingtip block, click on N to end the selection. I'm going to turn off those fringe points again. And let's go back over to the Cuts tab, and I'm going to change to a K computational cut. And I'm going to just click on the left arrow here to have it pop out to the K max plane. And what I want to look at is one of our new diagnostics, the donor volume ratio. So let's zoom up on this surface grid. And I'll move my rotation point a little bit here. And as I rotate around, I can see that this domain, or this computational plane for this block, has been color-coded according to this diagnostic, which is donor volume ratio. So this is another really nice visualization of the results from our chosen assembler and the assembly process Pegasus has given us, and allows us to see where we have a nice matching of cell volumes between blocks, and where we may need to do a little bit of work in order to make those volumes match up a little bit better in the assembly process. So again, another nice feature here in Examine for looking at the overset data. So that's actually all of the features for Overset that I wanted to demonstrate for you at this time. Next, I want to look at some other unrelated features, some new features that we're going to demo for you. So I'm going to select this block, this wing block that we have in the system, and I'm going to turn back on the rendering of my domains in the grid. And this first feature that I want to show has to do with changing the display attributes of entities in your project, and specifically a request that we've had a number of times from our user base, and that's to be able to change the display attributes of basically a block, which means updating all of the domains that that block is made up of automatically just by simply selecting the block. So I've done that here. I've selected this block, the wing block, and I'm going to open up the attributes panel using the toolbar option. And let's say I would like to have the domains for this block rendered as shading, and perhaps I would like to also change the color of the domains. So I'm going to change their color mode to per entity. Click on the color chooser, and maybe perhaps I'd like to see them rendered in orange. I'll click OK. And because I'm using the panel option for changing the attributes, I do have to click on this Update Entity Display for these options or changes to actually take place. Immediately I see now that my domains are shaded and all of them have had their color rendering changed to orange. So this is a really nice usability feature to speed up that process of changing the attributes for all the entities of a block, all the domains specifically, which has been a common request, as I mentioned. I would also like to point out that this feature also applies to database solid models. So you can actually now select a database solid model and change its display attributes and have that propagate automatically to all of the quilts that make up that model. So that's a really nice feature as well. So for both blocks and solids, you can use this new update to changing the attributes. While I have this block selected, I want to show another feature that we've recently added for V17.3 in the Examine command. So let's go back into the Examine menu and choose perhaps a minimum included angle as a diagnostic. And so I'm going to change my rotation point again here real quick, rotate back around, and I'll turn off the display of my domains. I'm going to go back to cuts. And the new feature that I'd like to point out is this new addition to the type of cut that you can use to look at your diagnostics inside your block, and that is user specified. So in addition to our standard Cartesian cuts, computational cuts that we've had in previous versions, you can now set up a more arbitrary or user specified cut. So I'm going to go ahead and activate that and turn on enable cutting. And it's defaulted to a cut plane here through the wing and through this block. And let's say I might actually want to see some cuts through this wing that are more or less perpendicular to the leading edge. So I'm just going to rotate my view around here so that I'm kind of looking along the length of the wing, and then just tell Pointwise to align the cut with my current view, which basically means a cut that's perpendicular to my view orientation. Now I can rotate back around, and I have a nice cut plane that is more or less kind of perpendicular, visually based, through the leading edge of the wing. And of course I can again select the edge of that cut plane and move that cut up and down the length of the wing. So this is a really cool addition to our cut plane options. In addition to aligning with the view, there's some other ways to specify this cut plane. You can click on Begin Plane Specification, and the choices that we have are point and normal, 3 points, selecting 3 points, and also if you have existing database planes already created, you can click on the third option, which is grayed out here because I do not have any database planes, and then select one of those existing DB planes to use. These options are very similar to creating planes in the Create menu, and so hopefully you should be familiar with all of them. Just as an example, I'm going to select 3 points, and let's say perhaps I might like to have a cut plane that is close to or about at the inward boundary or face of this wingtip block. So I can just simply come in here and mouse over the nodes of this domain or this face of the block and just select 3 of these in the display. As soon as I select the third point, it pops up a plane representation there in the center, and I can click on In Plane Specification, and I get a nice new cut plane through those 3 points. So that's just another example of how you can specify your arbitrary examine cut plane or user specified cut plane. So again, this is a really nice usability feature here for Examine. Alright, let's close back out of this panel and move on to the next feature that I'd like to illustrate for you very quickly. That's going to be related to creating connectors, and specifically creating connectors on database entities. And of course this model, like many that we work with from day to day in our grid generation projects, has a number of database surfaces. I'm going to go up to my Create toolbar and pull down and select Curve on Database as my creation tool. And what I see is my cursor changes when I mouse over these database surfaces. And as usual, based on projection in my view orientation, Pointwise is selecting the database entity automatically that I can draw or create new connectors on. Sometimes this can actually be a little bit problematic, having it determine these surfaces automatically, especially when you get to a situation where you're trying to create control points for a curve near the boundaries or edges of common database surfaces. sometimes it may be difficult to actually create the point on the surface you intend. Because of this, we've gone ahead and added a new feature in this panel that's in this frame near the bottom called On Database Options. Down here you can actually go in and specifically select a surface that you would like to create your curve on. So I'll click on Begin. I'll mouse over here to the display window and highlight the surface that I'd like to work on. In this example, for instance, this upper surface near the wing root. I'll just click on that to highlight it. I'll click on End Selection in the panel. And now my cursor that I'm using to create my connector is constrained to lie only on that database surface. So now I can only create or store control points there. So I'm going to mouse over the corner, click on that point. I can then create several new control points along the boundary or edge, just as we could before, and then possibly some interior points for some topology that I'm trying to create. So this is a nice new control for this particular command, and we have had a number of requests from users for this recently. So pick this up and give it a try. Alright, I'll click on OK, which saves that connector. I actually have one last feature that I'd like to demo, and then we're going to move back over to the slides to talk about the remaining new capabilities in version 17.3. This last feature that I would like to demo has to do with controlling your view orientation or changing your view orientation of your grid and database. A new option has been added to the View toolbar, and I'll mouse over here to the right, and you can see when I mouse over it, the tooltip calls it Align View to Surface. Basically, when I click on that, it opens a new panel. The panel is very simple. There's one text field where, if you like, you can type in directly a normal to which your view will be aligned. Or what users will probably end up using a lot more often is just simply mousing over database surfaces in the display and choosing a particular location that they'd like to align their view to. You can see the normal being rendered as I mouse over these surfaces. As soon as I click, the model immediately rotates and my view is aligned along that particular normal orientation. I can click over to the fuselage and do the same. Also, if I turn the display of my domains back on, and I'll just pan my grid over here a little bit so we can see this wing block, which I have shaded, I can mouse over that domain or surface as well, and I see the normal being rendered along the domain surface. And again, just like for the database entities, just simply click on the normal that I've chosen and the view updates immediately. So this is a nice new option that we've added in for changing your orientation. It can be really handy for situations where you're trying to do projection of connectors or domains onto database surfaces, and say perhaps you'd like to use a linear projection style instead of the default closest point. You can use this to quickly and easily change your view so that you're oriented normal to that database surface or surfaces, and then do your or perform your projection and get the results that you're looking for. So this is a cool new tool that we've added for changing your view orientation in 17.3. Okay, that is all of the actual demos that I wanted to do for the new features that we have. So I'm going to switch back over to my presentation that we were looking at before. And we have a list here of things that I want to talk about real briefly, including a bunch of I/O capabilities, some changes to the Layer Manager panel, some updates to projection that we've made, a nice change to the Orient command that we've had a lot of requests for recently, and then finally some changes for TRex and what we call a new drawing guide. So let's move through these and cover them quickly. First of all, for I/O, we've added in our CAE selection select solver panel 4 new solvers: ADS, Edge, GMesh, and LARA. And these are all highlighted in the image that I've taken here from Pointwise of the select solver panel. Additionally, we continue to always update the versions that we support for our native CAD file readers, which of course are provided with Pointwise. And so this table here highlights the versions that we now support for 17.3. Most of these have been updated, and so you can refer to this table for your particular CAD format that you like to use and see which version we're now up to for your particular package. Next, there's a new command that I'd like to point out in the File menu, Save Selection As. This is a personal favorite of mine in this new release. I've been needing this in several recent projects, and that's the ability to essentially select a set of entities, and it can be mixed. It could be a couple of blocks, some connectors and domains, whatever selection you need, and save only those selected entities to a new Pointwise project file. This is a really handy feature in those situations where you're trying to transfer certain parts of a project to a new file, possibly to pass on to another user, either because you're both working on a larger project and need to combine, or you just simply want to give somebody a starting point for some new work that they're trying to do. Previous to this version, if you wanted to accomplish this, you would have needed to just basically delete all the other entity information other than what you wanted to save, which could be a little bit more of a tedious process. So this is a nice new addition to save your selected entities. Additionally, when you save one of these files or save these entities to a new file, if there are any required supporting entities, such as parent entities, those will also, of course, be written to the file as well, regardless of their visibility or selection status. While we were adding Save Selection As, we also added a new set of commands referring to environment, saving environment or save environment command, and also file open environment. This is a new I/O capability that allows you to save and import what we refer to as environment type information. And there's a list down here which is probably not a completely all-inclusive list. There's probably additional items, but some examples are all of your tolerances in your file properties panel, layer descriptions and associated layer numbers, saved examine cuts if you have those in your system. Probably some of the really key things for users are boundary conditions, both for our TRex unstructured solver capability and also just for the CAE selection. CAE boundary and volume conditions, all of this information is considered part of the environment and can be saved to a file separately. It can also be imported from any existing project file, so even a file that has other data in it, including entities, you can read in separately just the environment information from that file using this command option. This has been another popular request recently from users to be able to store and restore this type of information. So give that one a try. Finally, for I/O, we do have a couple of other things that we've updated. Our support for STL import and export has been updated with the ability to read and write files that have multiple surfaces in an STL file. We also now write and import and support naming for those surfaces. And along with our Overset capability, we have upgraded our Plot3D support with new attributes for single multi-block, iBlank information, and 1D and 2D Plot3D files. For our layer manager, we've made a subtle change or a slight change to help usability. Our users and also ourselves here in the office, when we work on projects, we've found that we do use the assign feature of this panel quite a bit, basically assigning entities to new layers to try and organize your data in the system. This feature was down closer to the bottom of this panel, which was a little inconvenient, so we've moved it to the top in this Assign Layer frame. And we've added the ability to automatically include parent entities when we make these assignments. So you make your choices in the panel, in this frame, and once you've set it up, you just click on Apply to have those changes made. We've made some changes to the project command, and specifically in this first slide related to projecting connectors. In previous versions, as many of you know, when you would project a connector onto a database surface, the connector's grid points were actually projected onto that target database surface or surfaces, and as a result, each of the points was stored discretely in memory now as what we refer to as a general type distribution. General distributions are a little less easy to manipulate and update with new spacing constraints, and so generally we find ourselves and our users are almost always converting these over to a hyperbolic tangent in order to make those connectors a little easier to work on. So what we've done is we've added two new choices here in the project panel. The first one is called project points, which is the traditional form of projection that we've had in previous versions, which does result in type general distributions. So the points of the connector are projected. The second option is the project shape choice. This one basically goes in and only updates and projects the shape of the connector onto the database surface or surfaces. It does maintain the original connector point distribution and spacing constraints that you had on the original throughout the projection process. And we're probably going to find that this is going to be the default use for most of our customers in the future. The other projection change or addition that we have made in version 17.3 is the ability to project database points. It's a small new change, but it can be very useful, and we have had requests for this. So in the image you see here on the slide, I just have 3 database points that I've created, and I'm in the projection panel with linear projection chosen. We can see the little projection vectors there for how Pointwise is going to project those points onto the database. Another feature a lot of requests for recently is the ability to better see the normals for structured domains when you're using the orient command. In those cases where you need to export only your structured domains and you need to really have control over their orientation, it was a little more difficult to visualize. And so now we do show all 3 computational coordinates in this command, which obviously shows you the normal for the structured domain, and it makes that whole process much simpler and easier to see. For TRex, we've made a few updates or changes. The first one I'd like to mention is the Defaults tab, which is one of our primary tabs that's up all the time in the interface. You're all mostly familiar with it. We've added a whole new section of defaults for our TRex feature in the Unstructured solver. And I know this is going to make a lot of users happy that are working on complex grids with multiple TRex or unstructured blocks, and having to set up all these attributes for each of those blocks separately. Now you can just come in and set these up once as a default in this tab, and for every new block you create and use in the Unstructured solver, it will automatically inherit these defaults for you, and you won't have to go through that process. So that's a nice new usability feature for TRex. Additionally, on the TRex tab, we've added a new table at the top of that command panel. This table provides some grid information for domains that are set up with the match BC for TRex. And specifically, it's intended for use for domains that are structured and set up as match boundary conditions for TRex. The reason we've put this in here is because if these structured domains that you may have as a boundary are part of an adjacent structured block, the push attributes option in TRex is not going to push onto those structured domains because it would break those structured block topologies. So in those cases, it would be nice in some instances to have a little bit more information about those adjacent structured domains that are being used as boundaries so that we can set up our attributes for TRex, including growth rate and initial wall spacings, that better match those structured domains, and we get a better result from TRex in the end. So that's what this table is here for. Finally, the last new feature that I would like to point out here in our slides is what we call the drawing guide, and the command is show drawing guide, and you can find it here in the view menu. I have an example of at the very bottom. It's called show drawing guide, and you just check it like the other view features and it'll toggle that on. When you toggle it on, what you get is an overlay of the display window of what we see here in this example, basically a grid, no pun intended. This grid, though, cannot be picked. You can't choose these points or pick them for operations. It's really just there for reference. But it can be very handy and very powerful when you're rotating and aligning views of objects in your project, and also when you're freehand trying to create or draw connectors or other curves. It gives you a nice reference to line things up in a rectangular fashion in your project as you're working on it. So this is a nice little reference here that you can set up and turn on in your display window. Along with this, in the Edit Preferences panel, under the graphics frame, we have some additional options for the drawing guide. Of course, here you can also toggle it on and off if you need to. You can change the size of these squares that are in the grid in pixels. You can change the color of the overlay, and you can also adjust its transparency, so making it a little more visible or less visible. So those are the options that we have in Edit Preferences for the drawing guide. So that kind of concludes my presentation of our new features. Obviously, we have a lot of new capabilities that we've added to version 17.3. We are very excited about these new features here at Pointwise, and we hope you're excited about them, and we'll try them soon as well. This last slide here I have some information about the webinar itself. It will be available next week on our website at the URL that I have shown here on the slide. Of course, it'll be linked in on the front page of our website as well, so you don't really have to remember that. That's a real handy access to the webinar video so that you can go back and review something that you may have seen this morning. And of course, you can refer it to coworkers if there's something you think they may be interested in seeing as well. Additionally, we have some email addresses, that are shown here. If you have questions specifically about this webinar, you can email those to webinar@pointwise.com. And also, as always, myself and my colleagues are available for questions that you have about Pointwise at support@pointwise.com. So at this time, I'd actually like to hand over the webinar to Nick so that he can follow up on the questions that you have been giving us. And any new questions, of course, that you have now, please do use the questions field in the GoToWebinar interface to type those in, and Nick will cover those for you. So give me just a moment here as we switch over to Nick, and we will carry on.
Okay, good morning. As Eric said, if you enter questions, I will be happy to answer them. There were a few that came in during the webinar, and I'll review those now so that for the benefit of all the audience. There was a question about the arbitrary cutting planes in Examine. Specifically, the question was about the definition of an arbitrary cutting plane. Could that be done using the mouse? And I'm assuming the question there is, could you take an existing cut and somehow twist it using the mouse to get it into the orientation that you want? The short answer is no, that the orientation is arbitrary, but the definition of that orientation is only defined through the tools that Eric mentioned. However, the point normal definition method and the 3-point definition methods are extremely flexible. The points do not have to be something that you can select from the grid or the geometry. You can enter the points and or the normal in a entry field. So truly you can use those tools to define any arbitrary plane. There was one comment from a user about a new feature that they've been wanting, and that was save selection as. And I mention it here simply to note that that was something that we worked on directly because of the user requests we received. So I want to point out that we really do listen to your user requests, and if there's something that you feel strongly needs to be in our next release, please let us know through our support line about feature requests, because that's how things like that make it into the new releases. There was a question about the availability of the slides that Eric showed. Would they be available as an independent PDF file? The answer is yes. When we post the recording of this webinar to our website, we will also post a PDF file of those slides. There was a question regarding the drawing guide. The question is, does it rotate with the view or is it static? The drawing guide does not rotate with the view. It is locked to the screen X and Y, or horizontal and vertical axis of your screen, and your model, 3D model, rotates in essence underneath it. It's a true overlay in the window space. So that does never rotate, and there's no option to make it rotate. There was another question about orientation. This is tied into align to surface, which allows you to also specify that orientation. The question is does the orient display normal originate from the origin? It's a little bit more complicated. The normal is actually defined as the center of your view, so that center can actually move based on the current view that you have. It takes the centroid of that view and defines and uses the normal that you enter in that panel to set the view from there. There's a question specifically regarding overset assembly using Pegasus. Pegasus is a NASA software distributed through NASA Ames. It says, is Pegasus available for Windows? Pegasus, when you acquire it, is actually distributed in source form, and it uses Fortran 90. And we at Pointwise have been able to compile it successfully under Windows and utilize it under Windows, but that is something that each individual user will have to do. Another question about external overset tools. The two that we're interfacing with for this release is the Pegasus version 5.2 from NASA that I mentioned previously, and Sugar++, which is a product of Solaritas Simulation Technology. Pegasus is available freely for U.S. persons. It's distributed by NASA. You can do a search on the NASA website or in Google to find contact info at NASA to request that software. It is restricted to U.S. domestic users, however. The Sugar++ software is commercial software, but it is available worldwide, again, from Solaritas Simulation Technology. There is a question about which Overset solvers are available for CAE export in Pointwise. This is a little bit flexible. With Pegasus, you're largely restricted to use with overflow, although there are a number of other solvers which have adapted the overflow assembly data as their own, and so specifically speaking, we're not exporting for those, but they will work, and they have been demonstrated by other people to work with Pegasus. Sugar++ supports a variety of solvers, downstream CAE solvers, and that's something you'll need to check their documentation, but I do know that they support on the order of half a dozen different flow solvers. Sugar++ is easily extensible to proprietary solvers. Should you want to add Overset capability into your solver, they can help you to do so. They provide libraries to extend your solver to support Overset. The exam and demonstration of arbitrary cutting planes was only demonstrated for structured grids, and the question came in, is this possible for unstructured grids as well? And yes, the answer is that the arbitrary cutting planes, for instance, the example shown cutting along the spanwise locations of the wing mesh, that is possible for all mesh types in Pointwise. There's a question about actual unstructured block creation. That's a little bit outside the scope of this webinar. However, the tutorial specifically covers creating multiple block grids around different component bodies. There's one that uses both structured grid and unstructured grid, so we would like you to try those tutorials and then contact us directly with additional questions. There's a question about does the Overset capability utilize pulls to create a structured block? The Overset capability is independent of the mesh type, so if you desire to create a structured block with a pole and use it in your Overset assembly, that's fully supported. The only caveat there is that the individual flow solvers and the individual assemblers may require special boundary conditions in that case, and those are again documented in those assembler and flow solver documentations. There's a question about, are there any additions in the Glyph library? Yes, specifically all of the Overset tools have corresponding Glyph commands, so all of those were extended. For instance, you can query on a block basis and receive the Overset assembly information, such as the locations of fringes and the locations of holes. Those can all be queried by a Glyph. You can perform your assembly by Glyph, and there is also the other notable addition in this release is support for selections. So if you want to write helper type Glyph tools that take your current selection, that's now possible. Those are the last of the prepared questions. We'll remain on the line just a few more minutes if people have some questions they're working on. We have a new question regarding overset assembly. It says, can Pegasus or Sugar handle hole cutting for hybrid type meshes, meshes utilizing both structured and unstructured blocks? Pegasus 5.2 is a structured block only code. However, Sugar is an arbitrary type code. It can handle structured, unstructured, and hybrid grids. So if you have a need specifically for that capability, then you will have to use the Sugar assembler. Great. Eric and I want to thank you all for attending the webinar today and remind you that this webinar will be available for your review beginning next week on our website. Thank you.